Alright, question 20 here says when g of x is divided by x plus 4, the remainder is 0. Given that g of x is this function right here, which conclusion about g of x is true? Okay, well, in order to be able to do this question, it's probably ideal to understand what the polynomial remainder theorem says. So basically, if you have some polynomial, let's just do a little sidebar here, which if p of x equals x squared plus 7x plus 10. Well, in this case, let's say I put in p of negative 2. Let's see what that would give me here. I would get negative 2 squared plus 7 times negative 2 plus 10, which negative 2 squared is 4. 4 minus 14 plus 10, I would get that p of negative 2 is equal to 4 minus 14 would be negative 10 plus 10 is 0 in this case. And what this means is that our root here, 2, gives me 0 as my remainder. Meaning that if I took the factor that root comes from, which is x plus 2, I'm going to get a remainder of 0, meaning that this is a factor of my polynomial in this case. Which you can see that it will be. If I were to factor this using the AM method, this would go ahead and factor to x plus 2, x plus 5. Because 5 times 2 is 10 and 5 plus 2 is 7. So if p of negative 2 is 0, that means x plus 2 is a factor. So going back to our example over here, if it's saying that when you took g of x and you divided it by x plus 4 and you got a remainder of 0, that means that x plus 4 is a factor. Which means when you put the root back into the function, you should get 0. So the root of x plus 4, if you take x plus 4 and set it equal to 0, you'll get the root. So if I minus 4, that means when x is negative 4, and we substitute that into the g function, we should get 0. So g of negative 4 would be 0.